Okay, so we want to do example 8 and 11.1, which is really about solving exponential equations, right? We haven't really talked about this, but let's figure it out. It's not super hard. Okay, so this is telling me on the left-hand side that I have x minus 4 threes multiplied together, right?
Yeah.
You guys see that? Exponents tell me how many threes or how many things I'm multiplying together. The base tells me what the things are. So I've got threes, and there's x minus 4 of them.
Could you technically write that in the same way with like parentheses x minus 4 to the third?
That'll flip things over. So here I'm multiplying threes together x minus 4 times. If I swapped them, then I'd be multiplying x minus 4s together 3 times. That would actually be harder for me to solve. So let's not do that. So how many threes do I have on this side? 2, right? So I might think to myself, okay, I've got 3 to the x minus 4, and that's 3 to the 2, right? Now that the bases are the same, right? I'm gonna think to myself, okay, the bases are both 3s. If there's x minus 4 threes here and 2 threes there, then x minus 4 has to be 2. You guys see that?
How do you do?
This thing over here and this thing over there are the same thing, right? That's what the equal sign means.
So you subtract 4 minus 2?
So I just say, okay.
Does that mean x
No,
equals
what
6?
minus 4?
Okay, you got me all confused.
Okay, so I'm saying
I got
there
the
are some
bases.
3s over here, right?
Okay, I got the
And
bases.
that's the same thing as there are 2 3s over there,
Right.
right? So the number of 3s I have over here has to be equal to 2.
So x is 6.
So this piece and this piece have to be the same. You guys see that? So that tells me x minus 4 has to be 2, which tells me x has to be 6.
Okay. So you.
You guys see that? So that's add 4 to both sides. Get x is 6. And then I should check to make sure that makes sense. Right? So if I put in 6 up here, I've got 3 to the 6 minus 4. That's 2. So I've got 3 to the 2. Oh, that is 9. You guys see that? This is made a little bit harder by the fact that we don't have a tool from the next section. Well, the next section. In 2 sections, we'll get a tool that'll pull the tops off and get rid of the 3s for us. We don't have that tool right now, so we have to apply some reasoning. Cool?
Are there going to be ones with like multiplication of like x times 4, and that's like the exponent?
That one's kind of right here.
That's good.
Okay, so let's think to ourselves. All right. These are going to be hard to make the same, right? You guys see that? Why are these going to be hard to make the same? Yeah, because this is a common base, right? The common base is going to be hard to get over here because 4 and 8 don't really, there's not a power that makes 4 into 8 that's really convenient, right? No worries. So what's the common kind of base that makes 4 and 8? 2's, right? So I might think to myself, okay, 4 is 2 2's, right? So this is 4 to the x, right? 2 squared to the x. And over here, what's an eighth in 2's? 2 to the negative 3.
Ew.
Ew. Remember, negative powers flip things over. And then 2 cubed is 8. You can do this in a couple of steps if you want. So we could do 1 over 2 cubed, and then we could discover the negative power there. Cool? All right, so now what do I do with the powers on this guy? What's my exponent rule that tells me how to combine the powers there?
Okay, now go back. The -3, that's because the 8th was a fraction?
That's because an 8th, right, is 1 over 2 cubed.
Okay.
And then I'm saying, oh, this is on the bottom. I'd like it to be on the top so that it's in the same place as the other two. So I'm going to put a negative on the exponent.
Okay.
That's cool with that?
Kind of.
Okay, so I've got -3 2's on this side. How many 2's have I got on that side? I need a power rule, right? 2 times x. There's only one base there, right? So I multiply the exponents together. So now these are the same base. I could say, okay, I've got 2x 2's on the left and -3 2's on the right. So this number and this number have to be the same thing, right? You guys see that? So I get 2x has to be -3. Then how do I solve for x?
You should.
Yeah, I need to get rid of the 2 on the left-hand side, so I should divide by it. And so I divide both sides by 2. I get x is -3/2. You guys see that?
Wait, the book says 2x equals -3. It's the same thing, right?
That's what I have right here.
Okay.
And then I divided both sides by 2.
Okay.
Cool? You guys okay with that? Did you have a question?
And then if we plug that back in, it all shows up.
Yeah, and then if we plug that back in, so we're just kind of thinking, was that reasonable, right? So I've got 4 to the -3/2 power. Okay, when I've got a fractional power, the bottom means I should do that as a root, right? So this looks like the square root of 4 to the -3rd. It's the square root of 4. 2. So I've got 2 to the -3rd. That's 1 over 2 to the 3rd, which is
1/8.
1/8. So that seems like it worked. That's crazy. It is a little bit.
Wait, what did you do with the 3/2? -3/2. Oh.
This was my answer, and then I plugged it in to x to see if it worked. Just to give myself a double check, because I haven't done very many of these, right? Should we try this one? Is this one the same kind of problem, or is this one different?
Different.
Why is this one different?
It's probably the same in this trick question.
No, because it has that big old b squared plus 2 something something plus b squared. No, yeah. Well,
Don't
something-
multiply it out.
No, it's the other one.
So what's the difference between this problem and this problem? They're not quite the same.
Well, that one's it's cubics.
Yeah, there's a b, right? But forget the fact that it's a b. It's just a variable. So where's the variable I'm solving for? On the 2 previous problems, the variable was in the exponent. Here, the variable's in the base. You guys see that?
Isn't that just everything we?
These are kind of different flavors. Definitely don't cube both sides.
Isn't this just kind of like the stuff we've been doing?
No.
Yeah, this is much more like the stuff I've been doing.
We don't want to cube it.
Definitely don't want to cube this thing. If you cube this, you're gonna get a cubic polynomial, right? A degree 3 polynomial. You don't have a way to solve that.
Oh.
What you want to do instead is take the cube root of both sides. You guys see that?
Kind of.
That's maybe hard. We could think a different way. We could think that 125 is 5
Cubed.
cubed.
What you said not to
No.
I didn't cube both sides. I just rewrote this thing.
do. Okay.
You guys see that? I haven't actually done anything. All I did was rephrase. So now I've got this equation, which is b plus 2 cubed is 5 cubed. You guys see that? So I've got 3 of whatever this thing is multiplied together. And that's going to be the same thing as 3 5s multiplied together.
So it's gonna be a 3.
So this guy's got to be 5, which tells me B has to be 3. You guys see that?
No.
So that's saying B plus 2 has to be 5. One way to see that is to take the cube root of both sides.
Oh,
Yeah, so this means B has to be 3,
okay.
right? Subtract 2 from both sides. Get B is 3. You guys follow this?
So basically that B plus 2, you do that little thing that we did before, just take it out of cube on both sides because they're the same thing. No? Yeah.
There's a couple of ways you could see this. I would recommend that you cube root both sides.
Okay.
There's some other options, but cube root both sides is going to be the easy one. We haven't talked about why you would do that. What we're really doing is applying an inverse function to both sides. That's what we're going to learn today. So you guys see here I added 2 to this side, but I wanted to undo that, so I subtracted 2 from both sides.
Uh-huh.
That's applying an inverse function. I wanted to undo the adding of 2, so I subtracted 2. Here I wanted to undo the cubing of both sides, so I uncubed both sides. That's what a cube root does.
So if you put 3 on B, on the beginning to
Yep.
test it, will it work, right?
So if I plug it back in, yeah, it should work. So if I get 3 plus 2, that's 5. Cubed is 125.
Beautiful.
Check. You guys cool with these? These are a little tough at this stage because we don't have the idea of inverse functions. And so it's a little funny to say, okay, I've got these, now the powers have to be the same, right? Keep in mind that only works when the bases are the same. If they're different bases, you're not going to be able to do this. You guys cool with that? Just ain't going to happen. So if I had a slightly different thing, which was, say, 2 cubed is 3 to the x. Okay, see this? Do you see how this is different? The bases are different. I have no hope at all of solving this with the techniques we have. With logarithms, which we're going to learn in 11.3. We can solve this. We'll be able to do it. But for right now, this is just like, I got no idea on that one, man. Cool? So the bases aren't the same. You just kind of can't do anything with it.